Presenting Striker, a large open-source mech integrated with robot operating system. I built Striker to learn the skills needed to design and fabricate a large mobile robot from scratch, with locomotion, sensing, and manipulation capabilities, enabled by standard hardware like LiDAR and depth cameras. I've also used a standard software stack, like the MoveIt framework for inverse kinematics and motion planning, ROS serial for communicating with lower-level microcontrollers, and ROS control for position and velocity control joints. Educational platforms like Turtlebot can be useful for learning the fundamentals of robot development. They're also frequently referenced by serious researchers in the field to demonstrate specific concepts, like sensor fusion for extended reality. But by making robotics easily accessible, tools like Turtlebot can also cause robotics engineers to miss out on important skills like computer-aided drafting, mechanical and electrical engineering, design for manufacturability, machining, welding, soldering, and working with electrical components and connectors to build something real with their own hands. Striker is a mobile robot with omnidirectional or mechanism wheels, a LiDAR that's used for obstacle avoidance, as well as simultaneous localization and mapping, or SLAM, is located on a mobile base close to the wheels. 4 arms with solenoid end effectors can be used for a variety of manipulation tasks. The head has a pen tilt mechanism which can be used for remote teleoperation, and includes a PrimeSense Carmine 109 camera capable of capturing both 2D and 3D streams of the robot's environment. The power comes from a 12-volt marine battery, which simultaneously charges if the robot is plugged into an outlet. I built 2 power hubs with illuminated switches and XT60 connectors to distribute the power throughout the system, one mounted on the robot frame and one on the torso. An industrial NVIDIA Jetson carrier board from Seed Studio runs the robot software. The Jetson's hardware acceleration is helpful for prototyping autonomous functionality, running edge AI models like Qwen locally, Piper text-to-speech, Whisper speech-to-text, and YOLO object detection and segmentation. The robot's hardware is controlled by Teensy microcontroller units, or MCUs, all connected to a central USB hub. Each Teensy runs C++ firmware that uses the ROS serial library to respond to commands sent from the robot's computer and report back status about the systems they control. This summer, I exhibited the robot at Open Source Science Fair in California and Teardown in Oregon. It was nice to meet so many makers, even if I was continuing to bring critical systems online. Thankfully, the design was built to be modular, so it was easy to transport to the shows. I often got asked why this robot looks the way it does. Striker's good looks were inspired in part by the large robot mech from a Tokyo-based startup, Tsubame Industries, and partly by stage robots built for the UK drum and bass scene. The head also resembles a Lego Bionicle. All of the resources that can be used to build this project are available on the open source repository on GitHub at 01binary/striker. You may particularly find that the well-documented custom boards designed to control the various subsystems, as well as the firmware that runs on them, are easily adaptable to any mobile robot. So, I hope that this contribution provides at least some edutainment for the open robotics community and inspires others to build something great.